Hello everyone, welcome to the past paper discussion. We are in 12th question of this particular series and this is a phase portrait based question. Let's get started. Okay, so here system of coupled differential equations. Coupled differential equation is given over here. Right? And there is some description given and 4 kind of portraits also given. The general form of the equation is given to us. Dx by dt is ax plus by, dy by dt is cx plus dy, and 4 different phase portrait. The matrix ABCD has eigenvalues lambda 1 and lambda 2. Now we need to complete the table for 3 marks and 3 descriptions. The respective phase portraits we need to find over here. Got it? So let's move, and this will also helpful to recall those phase portrait conditions. Let's go. Okay, first one, I can see lambda 1 is equal to 2 eigenvalues. Let me note it first. 2 and 3, both are positive, and 1 is positive, 1 is negative, both negative. We have different conditions. So getting into the first part. My description of first description is both positive. When both positive, we call it as unstable node. Correct? And so more or less, it is no calculation, just directly we want to analyze and interpret the result here. It's an unstable node, and what happened, like the trajectories will rippled from the origin. And now I can filter out the options here. Rippled from the origin. So these are, okay. So 2 kinds, the ripple from the origin and approaches the origin. So the middle 2 approaches the origin. The first and last ripple away from the origin, right? So either it's now A or D, just with the eigenvalues, both are positive. So lambda 1, lambda 2 are positive. So it will be unstable. And then trajectories ripple from the origin. So the origin will act as a source and like it will push the pattern, right? So it will push out the trajectories and we will get an explosion like pattern when we see both positive. And one more thing is, for this unstable node, trajectories move along direction vectors. This is another important point we should know. Trajectories, okay, it will move, it will get ripple, but how? So 2 different ways we have. Trajectories move away along direction vectors. Okay, so lambda 1 is positive, its direction vector is 2, 1. Right? So along that direction, it will get in this direction, it got rippled. Why I'm not going to choose this is it's traveling parallel. It should ripple. So it's travel parallel towards the eigenvectors given. So that A is not the part. D will be the correct answer for an unstable node. Okay. Then moving to the next part. Second description. 2, lambda 1 is 2 and lambda 2 is negative 3. Okay. So in this case, 1 is positive, the other is negative. Correct? So it is called saddle point. We will have for second, it's going to be saddle point. It will approach the origin, like approaches the stable direction. So stable direction means it will approach trajectory, the path, like we can see over here, will go with negative eigenvalue vector. Okay, so this is my negative eigenvalue. And my trajectories will go along with this vector, 1, comma, minus 1. So this is 1, comma, minus 1 vector. X is 1, y is minus 1. So everything have that. Okay, and it is going 1 positive, 1 negative means for there will be a crisscross pattern over here. But now I need to select it's B and C are crisscross. So either B or C. Okay, so now in this two different negative eigenvalue trajectory approaches in that negative eigenvalue vector. trajectory will move away along the positive eigenvalue. Okay, I have the positive eigenvalue 2. Its vector is 2, 1. So this is 2, 1. It will move, it will approach that. So can you see it approaches that? That is what I need. And negative eigenvalue vector is 1, 1. It will move away from that. So it moves away from that and it is trying to approach this. So this you can see move away, outward direction. That's the only part we should take care of. And C matches, but when you check this, like this is moving away from that, but it should approach the negative eigenvalue vector. And it should move away from the positive eigenvalue vector. Okay, so right. And C will be the answer. Now lambda is -2. And yeah, this is -2. And of course, crisscross pattern, this will be the answer. There's just an reverse way of it. And it's still the same, right? One is negative, other is positive, means it will be saddle point, crisscross pattern. But as usual, trajectory will approach the negative eigenvalue. It will move away from the positive eigenvalue. So these are the things we can take. Approach. Okay, what is a negative eigenvalue? It will approach. So -2, its vector is 2, 1. So it's approaching it. Right? And positive eigenvalue, it will move away from that. Like it will go outwards. So it will be B. This completes. And lambda, yeah, so only these three possibilities, D, C, and B. Very simple. So now next part, we need to sketch the phase portrait for this particular lambda value. We have imaginary complex numbers as the eigenvalues. And dy by dt -12 at 3, 0. So negative slope is there. Right? Let's quickly recall this sketching part. Okay. So when you have a I have a complex number, that's okay. And we have to check for the real part, either it's positive or negative. Real part is negative. If real part is negative, then you will have a spiral kind of structure. Then spiral means like it will go like this and then it will go like this, right? So what kind of spiral should I like? Which direction it should be? That is important. The phase portrait will go like towards the origin. The spiral will get formed. So like this, okay, and in both the ways, right? And direction we need to find. The direction is imaginary part of the eigenvalues, which is 3i and -3i. And this will give us the direction. Okay, so negative real parts means the spiral will sink and the direction is going to be the clockwise direction. And also we can see that dy by dt is equal to -12, right? So -12 at the point 3, 0. So the velocity is downward, like going down at this point. So this suggests the phase portrait should begin by moving downwards when starting at 3, 0. Right? And these are the things we should keep in mind. The direction is clockwise. Since we have the complex. And the real is negative, it is a spiral. Okay, so how to start? At least it is expected the spiral should cross x-axis twice and 3, 0 is must. It should cross. Let's mark it. From the origin, if I just make like this, in the clockwise direction, as we have mentioned. Okay, the spiral means not in the one direction. Clockwise, we can make this way also. Wait a second. same clockwise direction, but in this way it should move. Like this. So this will complete the spiral structure. At least twice it should cross, and 3, 0 crossing is important. And so the spiral will be forming in this. So many spiral patterns will form, but it's towards the origin, right? And that's it. This problem is over. Yeah. Thank you for listening. Keep learning. Let's meet in the next video.